Hello, Andy here from GAA Tech. This is an unusual video for me as it's going to be a voiceover, and it's not about cutting carbon fibre or FR4. It's regarding a Chinese imported CNC tool height setter. Now if you've got one of these or something similar, this video may well save you from breaking a tool. Okay, so it arrived. The box was slightly damaged and it wasn't particularly packed very well, just a little bit of bubble wrap. But the thing itself was, it was nice, it was heavy, it was lovely to hold in your hand. It comes with a curly cord, as you can see, and also an earthing clip should your machine need that. So on first inspection I was really pleasantly surprised and pleased. It's got a magnetic base, so you can store it if you want to by clipping it onto your machine if your machine is metallic. And the brass bit, as you see in the middle there, is sprung loaded and it depresses about 10mm. So the idea of me upgrading to this gadget was my tool setter is fixed. So once you've tested it's working, you put it under your tool, the tool will come down, touch it, and it will set your tool height. However, if something goes wrong, you don't get a chance to stop your machine, and you would likely break your tool and possibly twist your gantry. So the idea of me upgrading to this gadget was it was sprung loaded. So after you've tested it's working, you put it under your bit, you press auto 0, the spindle will come down, as you'll know, touch the top of the gadget, it will retract slightly, go back down again, and it will set your 0 height in Mach3 or UCCNC, whatever you're using. So, and if something goes wrong, say that the spindle's descending and the bit touches the top of this brass bit, you've got, as long as your machine takes to move that further 10mm to stop the machine before you get the machine pressing against something rigid. So this was the whole idea. So once I got this out, I thought, yeah, I need to know how this thing works, because it's weighty, it looks well made, however it's come from overseas, and if you've ever bought stuff from overseas, some of it's very good, a lot of it's junk, and then you get that bit that's in between. And I just wanted to know how this thing works. It was only held on by screws, so I thought, yeah, let's open it up. So that's what we're going to do now. Through this video we're going to open it up, find out how it works, and then find out why I'm so glad I never put this under my CNC spindle and used it out the box, because it's friggin' dangerous, and I'll explain that in the next coming slides. Okay, so here we have like the dowel rim bottom separated from the aluminium tool setter, and that's actually quite well machined with countersunk screws. One of the screws didn't thread in very well. You could push the screw down into the thread by about 2.5–3mm before the threads would catch. Now I can't work out why that was, because the threads looked like they were straight and not tapered, but that's one of the things with Chinese. The silver bit in the middle of the blue base is a magnet, so you can remove that if you want to. Again, the screw holding that on was a 4mm screw, and that isn't particularly threaded very well either. And then at the 6 o'clock position, where you see the black cable come in, there's actually 2 grub screws. One grub screw is retaining the cable to give it some strain relief. That's the silver one right at the bottom, and we'll cover that in a second. And then the second grub screw, which is the black one, is actually holding the cable, and that's the biggest downfall of this gadget. That is the part that is making the cable connection between the cable and the aluminium body. And you can see in the slides as we go the strain relief, etc. They just used an old piece of cable to give it strain relief. It was strain relief in the cable, so yes, it did work. Now the inside of the gadget, now I've taken the top off, reveals two holes that they've sort of tried to countersink, and they've done that to give the top part that I removed, which is the silver bit, continuity to the anodized blue part. Now if you look down the threads, it's not very clear in this slide that the threads are actually anodized as well. So when you actually screw a screw or a bolt into the threads, the chances of you getting 100% continuity all the time is low, because something that's anodized doesn't conduct. So I believe they've tried to scrape away the anodizing here to get two of the bolts to make continuity between the silver part, and that's the really important part of how this gadget works, in continuity between the body and the sprung loaded plunger. And we're going to cover that as we go on. So the internals is a spring, obviously it's sprung loaded, and that is a stainless steel spring, and the brass was a nice bit of turning, so no complaints there whatsoever. Now the inner ring part with this 2012 stamped on it, it's purely there to allow the brass part seen in the last slide to slide up and down nicely, because I believe that if you had brass sliding against anodized aluminium, it wouldn't slide very well, it'd catch. So this part has nothing to do with continuity between the cable and the brass part where the tool's actually going to hit. And this is the subject matter of this video, why the tool is so dangerous in the state it's delivered to you, because the continuity path between the end of the cable, it joining onto the anodized blue base, then the blue base making continuity to the brass bit, it has a massive flaw in it. And I can't reiterate, if you've got one of these, please take it apart and check how yours works. I mean, I paid, I think it was under £20 shipped from China to the UK, and it just was bloody dangerous, and hence this video. And anyway, I'm going to put a few more slides up, and we're going to move on, and we're going to show you the continuity path. Okay, the continuity of the whole gadget is as in this slide. You're relying on the brass plunger touching the aluminium silver part when it's plunging. You have to trust me on this. The difference between the brass part and the aluminium part was 0.16 millimeters to allow the parts to slide into one another. Now when I press the plunger central to the silver part, I lose continuity because the brass part is not actually touching the aluminium. So when this gadget is in operation out of the box, should your tool, when it's plunging to on top of the setter, push the brass bit totally symmetrical to the aluminium part, i.e. the brass part is not going to rub on the aluminium, which it can do, because I got it to do it regularly by pressing the probe down, simulating my tool, and if I was careful there would be loss of continuity. So should that happen, your CNC machine wouldn't realise that it's touched the top of the tool setter, and it would continue to plunge until continuity was made. Now that's, remember, not continuity between the tool tip and the brass part, it's the continuity of the tool setter itself between the brass part and the aluminium. And that's the whole flaw of this bloody tool. It's the way it's been designed. Outstanding what they've done. Okay, to improve the continuity path, I wanted to make another path for continuity to get to the brass section. So my first thought was I need to get better continuity from the silver aluminium top section to the blue body. So all I did there was got some wet and dry, and I scoured off the anodizing underneath the plate. So once the plate is bolted on, you've got a large contact area for the aluminium to now contact the body. So on the original design of this tool, now when the brass plunger is plunging and it rubs against the aluminium, you're guaranteed that you're going to get continuity, because you're not just allowing, as shown in the previous slides, the two screws that had been sort of counterbored for that to give continuity. Now I was confident that the body would always have continuity with the top, but obviously I wasn't happy with that, because I've already explained that the major flaw with this gadget is the brass section has to rub against the aluminium top for continuity to happen, and for that then to send a signal to Mach3 or UCCNC. So what I then did was I thought, well, I need to get continuity from the spring, because the spring is always in contact with the brass. So my first idea was I drilled a 13mm partial hole in the bottom of the device, and as soon as I've done that, I thought, you bloody idiot, why didn't I use my CNC to route a pocket for the spring to sit in? So that's what I've done, and you can see in this slide here, you can just see that the sort of counter boring on the bottom hole in the middle is where the drill bit made its hole, and then I set a tool path up using a 3mm single flute bit, and I pocketed a 2mm hole for the spring to sit in. Now the spring does sit in there tightly, and that's going to give good continuity. So I thought that's a massive improvement. Then to check that I was getting continuity between only the spring path and not from the aluminium top section, I used some paper which I could just force one thin sheet of paper around the brass plunger and the aluminium top. When I checked continuity of that, there was no continuity, so when I reassembled it, I was checking the continuity path of the spring only, and that always gave me continuity. So I was happy with that. So now all I had to do was reconnect the wire to the whole gadget itself. Now I couldn't connect the wire to the spring, firstly as it's stainless steel and I didn't think it would solder on there very well, and secondly because the spring is always going to be moving when it gets compressed, I was worried about the solder, if I could get it soldered, would fail. So I thought, well, I can mill out the bottom of the puck and use a stainless steel, a steel washer to press the cable against the bottom of the puck, and that's what I did. So here in the slide you can see I've milled out a large penny washer. I think it's 1 mil depression for the washer to sit in there nicely, and then I thought about, well, if I mill a 2mm deep channel, because my cable was what was it? It was 2.6mm. Then when the bottom base is bolted back on, the bottom base will squeeze the cable very slightly, and that will give it strain relief. You could always put some hot glue in there as well if you made the channel slightly bigger, but doing it this way, it worked really well. So I was really quite pleased with my ingenuity for the afternoon. So during final assembly, I had to use a 3mm bolt. So I took the magnet off because I actually needed the longer bolt that they supply that holds the magnet on to actually hold one of the Delrin top on because one of the bolts wasn't gripping very well in the threads, and a slightly longer bolt, which the magnet bolt is, threaded in much better. So here's a temporary 3mm bolt going through with a couple of washers onto the penny washer, which is now squeezing the bared cable, so the conductor of the cable, between the penny washer and the milled pocket on the bottom of the puck. And inside the gadget it's a 3mm nylock nut holding it all together, so there's no way that's going to come out. So when I probably find my soldering iron, I might actually solder the wire onto the washer, and that's another path that omitted that could fail. But you know, this is now much better than it was. I've got two paths of continuity from the cable connection, so this connection going through the cable onto the penny washer, onto the bottom of the puck, up the spring, then the spring is touching the brass, and then the original way that the gadget was made, from the body of the puck onto the top aluminium section of the puck, and then when the brass plunger is depressed, as long as that rubs against the side, that's the second path of continuity. So I thought I'd make this video because I just felt this could be so dangerous. You know, 9 times out of 10 the thing may work, but when you've got your most expensive bit in the tool setter, okay, you check the tool setter initially for continuity, because that's what you should always do to make sure Mach3 is actually going, or CN your UCCN3, you're going to see the tool setter touch. But when you actually go to use it, if the brass bit doesn't rub up against the aluminium top, your machine's not going to stop. And if you're not quick enough, your machine was going to continue plunging into your well, the tool setter, and break your tool. And you know what it's like. It's either going to be your most expensive tool, or it's going to be the last tool that you've got to finish your job. So yeah, there's never a good time to break a tool, especially when it's your last one or your best one. So I hope you've enjoyed this video. I'm sorry about the voiceover, but it was long-winded me sort of making or finding a way how to make this damn device better, and I feel that I have improved it. I would welcome any comments for further improvements that people may know, and I'd be really pleased to know that, you know, you people out there that have a device from the same seller, and I'll put that in the description below, as someone on eBay or other sellers, because you know they all sell the same stuff, don't they? And whether you've taken yours apart and you've just found that when you take out the two initial grub screws, that one is retaining the cable and one is actually, well, it's not really, yeah, it is making the connection between the end of the cable and the aluminium body. It's just that's a terrible connection. But then the way the thing works was terrible. I think I've improved it. This is Andy from GAA Tech, feeling happy with himself, signing off, and I'm going to go in and enjoy using the tool setter. Cheers for now. Puck, just showing you the tape, and I'm going to do a separate video on the tape. So I've stuck the puck down onto a used MDF spoil board. You can see it hasn't been skimmed for a while, but I've just stuck the tape straight on, and this is not, well, let's do it right-handed because I'm right-handed. This is not moving. I'm just going to now peel it off. Let's get you in shot. Blimey. So it's peeled off. You can see it's brought some of the MDF off, so if you use it a lot it probably will upset the board, but that's just coming straight off. Difficult to do one-handed, and it's leaving no stickiness on the part. Anyway, let's continue with modifications of the puck. Cheers.